Hello, geography students. This is Mrs. Politsky, and I have some notes over map making, understanding map projections. So, as we go along, make sure you fill in the information that you need. We're going to talk a little bit about what a map projection is. And the big thing for you to realize is that a map is a flat diagram of all the Earth's surfaces. The Earth we know is round, but a map, for the most part, obviously, is a flat surface. So, map makers have created different ways of showing our rounded planet on these flat maps. And these different ways are called map projections. Uh, because the Earth is round, there's no way to show it uh, accurately on a flat map. So all maps are distorted in some way. And the distortions involve things like distance, direction, shape, and possibly area. So map makers must choose the map type of projection that is best for their purposes. And there are really three main map projections: the cylindrical, the conic, and the flat plane. So as we go along, we're going to take a look at some of these and kind of look at the pros and cons of some of those. So we're going to start with the cylindrical. And cylindrical projections are based on a cylinder wrapped around the globe. So if you look down in the bottom left-hand corner, you'll kind of see a diagram that is trying to mimic this idea of a cylinder wrapped around the globe. The cylinder touches the globe only at the equator, and the meridians, which, if you remember, that's your lines of longitude, are pulled apart and are at times parallel to each other instead of meeting at the poles. So if you take a look at the map projection that is kind of in the bottom right hand corner, you might see that. This causes land masses near the poles to appear larger than they really are. An example of a cylindrical projection is a Mercator projection, which is used by navigators because it shows the true direction and shape. However, it does distort the size of our land masses, especially near the poles, and it will probably also distort distance as well. So if you take a look at this Mercator projection below here, you'll see that the northern areas of North America, Greenland, parts of Canada, or if you look at Asia, or even down at the South Pole at Antarctica, those land masses appear to be very large compared to what they really are as far as their size. All right. The conic projection. This is a projection that's based on a cone that's placed over the globe. Conic projections is the most accurate along the lines of latitude where it touches the globe. It remains almost true to shape and also true to size. Conic projections are most useful for showing areas that have long east-west dimensions, such as the United States or the middle latitudes. The problem here is it distorts distance and also direction. We also have the flat plane projection. Flat plane projections are based on a plane that touches the globe at one point, such as at the North Pole or the South Pole. Flat plane projection is useful for showing the true direction for airplane pilots or ship navigators. It shows true but distorts, or true area but distorts the true shape of a landmass. Other types of projections, the sinusoidal projection. This is sometimes known as an equal area projection. All of the parallels at the center of the meridians are straight lines. It distorts shape away from the central meridian, so there's no true distance. You also have some polar projections. They form in a form of azimuthal projections. All lines intersect at the poles. It distorts size and shape of the edges, but distance and direction are accurate. It's also good for navigation. Uh, we also have the goods interrupted equal area projection, which is kind of below here to the left, and it shows equal area map projections, but it shows true size and shape, but it really distorts the distance. So when you look at the projection that's down here, you do see the true shape of places like North America and South America, but uh, as far as distance, it's a little off. The Robinson projection, this distortions are kind of minor. Basically, it's a polar region flat. It shows the eastern and western map edges very accurately. So if I'm looking at, let's say, Australia on this map, it, for the most part, kind of has the right shape to it. And the proportion is pretty accurate in comparison to the rest of the land masses nearby. The Gull-Peters projection, this is also an equal area projection. The standard parallel as far as the degrees here is 45 degrees. So when we look at this, there's a 45-degree distance between lines of latitude. Land masses are accurate. South America, Africa, Southeast Asia are the correct size in relationship to places like North America and Europe, but it distorts shape and distance. All right, these are a few close ups of those. All right, thank you very much.